Hello, welcome to Maths with EJD. In this video, I'll be showing you the Python code for cut and paste solution to an integer linear programming problem. It's the problem that was solved in the last video manually using the cut and plane method. But then I present you the Python code. Again, the problem statement is what you see there. We have to maximize z equals 3x plus 2y, subject to the constraint x plus 2y less than or equal to 5.5. 2x minus y is greater than or equal to 1, then x and y are both non-negative. In addition to them being non-negative, they are also integers. So that makes that takes it a bit higher than when you have a normal linear programming problem where the values of x and y, as far as they are positive, we are good to go. But here we have to also ensure that they are integers. So the Python code implementation, you can see everything is just in 22 lines. And from my experience so far, I've seen that Pulp being that Pulp is a library particularly designed for optimization for linear programming. It seems to be cuter than linprog in scipy.optimize, right? So so I present you that Pulp solution today. In fact, if you remove all the comments and everything, there are how many comments? One, two, three, four, five, six. So all those hash are actually anything that starts with a hashtag is actually a comment. So if you remove the comments and the spaces, you have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have just 10 lines of code to do that thing we did for almost 20 minutes when we're solving the problem manually. Okay. So in line 4, right? That's where you create the linear program. You are maximizing. So if you're maximizing, you state it that you're maximizing. Then in line 7 and 8, it tells us the bound of your variables. Now, the beauty of pop is that at this point now, you can already set the lower bound is 0, meaning that it is never going negative. And the category of the integers is actually, and the category of the variable is that they are integers. So by doing that alone, you have automatically restricted the variables to be integers and nothing else. Okay. And then another beauty of pop is that you can define your problem directly. In linprog, you have to code it, like you have to say -3, -2, and things like that. But here you can just write the problem directly. So the objective function is z equals 3x plus 2y. So you just say LP is plus, the LP that you stated here, right, is plus equals 3x plus 2y. Then you have the constraints in lines 14 and 15. So you also state the lines, the constraints directly. You have LP plus equals x plus 2y less than or equal to 5.5. LP plus equals 2x minus y greater than or equal to 1. Then, of course, you have to state that, okay, this is constraint 1, constraint 2. And then the actual solving is happening in line 8. So solve the problem using the default solver. The default solver actually uses cutting plane method automatically. So automatically the solution you're going to get is going to be it's going to be integers, right? So it gives you the optimal solution, x value, y value, and then the objective function value straight. So in just a few seconds, you have your answer. So the optimal solution, x equals 5, y is 0, and the optimal objective value is z equals 15. That was exactly what we got when we did it manually, right? So you see, Pop is looking like Pop is going to take the crown from Limprog based on this kind of efficiency. Now, if you're going to do the same thing with Limprog, right? You discover that you have to write like several lines of code to do the same job. So Pop looks like the boss. Of course, for obvious reasons, it's specifically designed for linear programming problems. Okay. So that's what that has been as far as the Python code for cutting plane solution to the integer linear programming problem is concerned. So if you have not subscribed to this channel, please do that right away because you have a lot to learn here, right? And of course, you want to hit the notification bell so you can always get alerted each time a new video is released. Then don't forget to comment. Let me know if you want me to teach a topic or solve a problem, and like and share so that more and more people can have access to all this great content. So till I see you again, have a great time. Bye.